Hello everyone. In this question it is asked that we are to find the sum of all integral values of lambda for which the equation lambda square plus lambda minus 2 times x square plus lambda plus 2 times x is less than 1 for all x belongs to real numbers. Okay. So we are given a quadratic equation in x and the constants contain a parameter lambda. Okay. And we are to find the sum of all integral values of lambda which satisfies the given condition. Okay, so first of all, the expression is lambda square plus lambda minus 2 times x square plus lambda plus 2 times x is less than 1. Okay, for all x which are real. So if we take all the terms to the left hand side, we see the expression now changes to lambda square plus lambda minus 2 times x square plus lambda plus 2 times x minus 1 is less than 0. Okay. So if you compare it with the standard quadratic expression ax square plus bx plus c. Okay. On comparing with that, we see a is lambda square plus lambda minus 2, b is lambda plus 2, and c is minus 1. Okay. Now, this is the quadratic expression, right? Now, this value of quadratic expression, this say f of x equal to ax square plus bx plus c. Okay, this quadratic expression is less than 0 whenever in the graph of the curve, say this is the x-axis, right? Let's say this is the x-axis. Okay, if this expression is less than 0, then the curve is like this. Okay, it cannot touch the x-axis, otherwise it will have roots. Okay, and it is strictly less than 0, and the curve will be downside. Okay, so this implies that this is true if and only if your a is less than 0, that is coefficient of x square is less than 0. Okay, and the second case is it does not touch the x-axis, right? If it touches the x-axis, this means there is a real root. Okay, whenever it intersects with the x-axis, this implies there is a real root. If it doesn't touch with the real x-axis, this implies that there are no real roots. Okay, that is the discriminant d or delta is less than 0, right? That's why it is not intersecting with the x-axis. Whenever these two conditions are satisfied, the expression is always less than 0. See, the curve is below the x-axis, right? Y is below the x-axis. This is y, right? Fx is y. So if this is below the x-axis, it means its value is negative. Okay, and this happens only if this a is less than 0. If a is greater than 0, the curve is above the x-axis, right? It is open vertically upwards, whereas if a is less than 0, it is open vertically downwards, and the discriminant is less than 0, which means there are no real roots or imaginary roots if we go in complex, but here x is real. Okay, so these are the first two conditions for if this quadratic expression is negative. Okay, the value of this quadratic expression is negative under these two conditions. So if we apply these conditions in our case, if a is less than 0, this condition 1 implies that lambda square plus lambda minus 2, this is less than 0. Okay, so if we factorize this expression, we get lambda plus 2 times lambda minus 1, this is less than 0. This further changes to lambda minus of minus 2 times lambda minus 1 less than 0. Okay, so if product of two numbers is less than 0, this implies that the number is larger than the smaller number and smaller than the larger number. That is, lambda must lie, if this is minus 2 and let's say this is 1, if lambda lies in this region, okay, if lambda lies in this region, the this term lambda plus 2, let's say it is 0, right? So this lambda plus 2, this becomes positive, and if we consider 0, this is 0 minus 1, so this will become negative, right? So we have a positive and a negative term. The product will become negative, right? So this is why lambda is larger than the smaller value and smaller than the larger value here. Okay, so lambda lies in this region. So this implies lambda in this interval, lambda can take the integral values. It can take the values -1 and it can take the value 0. It cannot take any other value, right? Because both -2 and -2 and +1 are strictly unequal. Okay, so these are the two possible integral values so far. Okay, now applying the second condition. Second condition is your discriminant is less than 0. So this implies your b square minus 4ac will be less than 0, right? So this implies b is lambda plus 2. Okay, so this implies this lambda plus 2 whole square minus 4 times a is lambda square plus lambda minus 2 times c is your -1. Okay, -1. This is also less than 0. Okay, so on further simplification we get lambda square plus 4 lambda plus 4 times, if we multiply this -4 with -1 we get +4 times lambda square plus 4 times lambda plus 4 lambda and plus 4 times this -2 becomes -8. Okay, this is less than 0. So on opening the brackets we see this becomes 5 lambda square plus 8 lambda minus 4 is less than 0. Okay, so can this be factorized? Product is -20, sum is 8, so 10 minus 2. Yes, 10 minus 2. Okay, 5 lambda square plus 10 lambda square, 5 lambda square plus 10 lambda. So we have lambda plus 2 and then 5 lambda and minus 4 by plus 2 is -2. Okay, so this is less than 0. So this can be further changed to lambda minus of -2, and if I take 5 out of this second factor and divide both sides by 5, since 5 is a positive number, this inequality won't change, right? 0 by 5 will be 0 again, and since 5 is positive, this inequality will remain as it is. Okay, if I divide with a negative number, the sign will change. Okay, so I am dividing this second term by 5 on both sides. Okay, so this will become lambda minus 2 upon 5, and this product is now less than 0. Okay, so again if I draw the number line, this is -2, somewhere here is 0, and 2 by 5 is like 0.4, so this is 2 by 5. Okay, so again if the product is negative, if I take say 0 again here, if I put lambda equal to 0 here, 0 lies between these two values, this will become positive, right? 0 plus 2, this is positive, and 5 times 0 will be 0, and 0 minus 2, this is negative, right? So we have a positive and a negative product in terms. Okay, so this product will become negative. So this will imply that lambda will be larger than the smaller value and smaller than the larger value. Okay, that is lambda will lie in between these two values. Okay, so in this case lambda can take the values, integral values, -1 and 0, and no, it cannot take 1. Okay, 2.5 is like, this is 0.4. Okay, so it is less than 1. So these are the two values it can take. Okay, so we get the same two values, -1 and 0. So apparently the sum should be -1 plus 0 will be -1. Okay, but now let us focus on this given inequality for one more time. Okay, if I write this equation to be star C, okay, star, from star, okay, we get lambda square plus lambda minus 2 times x square plus lambda plus 2 times x. This is to be less than 1 for all x belongs to R, right? Now if I factorize this term, okay, this will become lambda plus 2 times lambda minus 1 plus lambda plus 2 times x less than 1. Okay. Now we got two integral values of lambda, right? Same two values, -1 and 0. Okay. These two values are true, corrected. Okay. Now if I look at the value for in this equation, if I take lambda equal to -2, okay, we see what happens in this equation, right? This term will become -2 plus 2 times -2 minus 1. Okay, this times x square plus -2 plus 2 times x. Okay, if we take the take lambda to be -2, we see this value becomes 0, right? So it becomes 0 times x square, 0 times x square, and the second term, this also becomes 0, right? So this becomes 0 times x. Okay, so this is 0, 0 times x square plus 0 times x. Okay, this is 0 for all x which are real. You can take any x here, the value will be 0 itself, right? Now this value of 0, this is less than 1. Okay, 0 is clearly less than 1. So this equation, this double star equation, this inequality is satisfied for lambda equal to -2 also. Okay, this inequality, the original inequality that was given in this question, we were to find the integral values of lambda, sum of all integral values, for which this inequality was true for all x belongs to real numbers. Okay, so we found two values, -1 and 0. But when we take the value lambda equal to -2 and plug that value back into the inequality, we see that the expression is also satisfied irrespective of any value of x. Okay, that is, you can take any real value of x, this inequality is satisfied anytime. Okay, so we have to also consider this value lambda equal to -2 since it satisfies the given condition. Okay, therefore lambda equal to -2 also satisfies the given condition or inequality, whichever was given. Okay, therefore sum of all possible, all integral values of lambda for which the given inequality holds true equal to, we see that we have this value -1 and 0, we get the same value from both the condition. Okay, so there is no overlap there, and the other condition is this lambda equal to -2, right? So we get three values, -1, 0 and -2. If we sum them, we get the sum to be -3. Okay, so this is your final answer. In the book the answer is -3, and I had to try for some time in order to get this -2 value. Okay, I also first got these two values, and I discarded the HKs because while solving it was strictly excluding -2 and 1, right? In both condition it excluded -2, so I discarded that case. But after observing in the original inequality, when I plugged back -2, I saw that the inequality was true. So this was the primary condition, right? All these conditions of this a less than 0, d less than 0, these are like secondary. The primary condition is whether it satisfies this given inequality or not. Okay, this is the primary condition. So lambda equal to -2, if it satisfies this inequality, then that value should be considered. Okay, so this is it. If you have any doubt, you can ask in the comments, or if you think there is any mistake in any steps, you can highlight there. Okay, I will respond to you. Okay, so from -3 is the final answer, and there are three integral values of lambda. Okay, thank you.